Hello students, today we are going to solve exercise 3.1 second and third question. Before doing second and third question, you should have to note some important points, that is, if we have given a pair of linear equations a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, then there are three cases arise. Okay, then there will be three cases. Case 1, if a1 by a2 not equal to b1 by b2. Here a1, a2, b1, b2 and c1 and c2 are coefficients of x, y and constant respectively. Okay, that is coefficient of x are a1 and a2, coefficient of y b1 and b2, constants are c1 and c2. So first we have to take a1 by a2 and b1 by b2. If a1 by a2 not equal to b1 by b2, then we can say that when we plot the graph of the equations, then we get there are two intersecting lines. That is, the lines are intersecting. If the lines are intersecting, then we know that there is only one solution. That is, we can say that unique solution. There will be unique solution. If solution is there, then the system is said to be consistent. If solution is not there, then they are inconsistent equations. If solutions are there, then they are consistent equations. Okay. Once again, case 1, a1 by a2 not equal to b1 by b2, then the graph of the lines are intersecting and there is a unique solution and the system is consistent. Solution means system is consistent. Okay. Case 2, if a1 by a2 equal to b1 by b2 not equal to c1 by c2, then the lines are parallel. The lines are parallel and there is no solution. Lines are parallel means there is no common solution, isn't it? Therefore there is no solution and the line and the system is inconsistent. If there is no solution, then the pair of linear equations are inconsistent. Okay, now case 3. Case 3, if a1 by a2 equals b1 by b2 equal to c1 by c2, then the lines are coinciding or they are overlapping. Okay, there are infinitely many solutions and the system is consistent. Infinitely many solutions means there are solutions, therefore they are consistent. The system is consistent. Okay, now second question, on comparing the ratios a1 by a2, b1 by b2, c1 by c2, find out whether the lines representing the following pairs of linear equations intersect at a point are parallel or coincident. That is, we have to check whether the given lines are parallel, coincident or intersect at a point. For that, first we have to find a1 by a2 and b1 by b2 respectively. Here the first question is 5x minus 4y plus 8 equal to 0, 7y plus 6y minus 9 equal to 0. First you find a1 by a2. Okay, a1 by a2, that is equal to coefficient of x, that is 5 by 7. In this question it is 5 by 7. a1 by a2 equal to 5 by 7. Now find b1 by b2. b1 by b2 equal to minus 4 by 6. After cancellation, you get minus 2 by 3. Okay, minus 2 by 3. After cancelling, we get minus 2 by 3. So we can say that a1 by a2 not equal to b1 by b2. a1 by a2 is not equal to b1 by b2. If a1 by a2 not equal to b1 by b2 means the lines are intersecting. So we get the lines are intersecting lines. Lines are intersecting. Okay, there is a unique solution. Only one solution will be there. The lines are intersecting. So in first question we have a1 by a2 not equal to b1 by b2. That means the lines are intersecting. Second question, 9x plus 3y plus 12 equal to 0. 18x plus 6y plus 24 equal to 0. First find a1 by a2. a1 by a2 equal to 9 by 18. After cancellation, you get 1 by 2. Now b1 by b2. b1 by b2 equal to 3 divided by 6. That is coefficient of y. 3 divided by 6. Again cancelling, you get 1 by 2. Now find C1 by C2. C1 by C2 equal to 12 by 24. Cancelling, you get 1 by 2. So we can say that in this question A1 by A2 equal to B1 by B2 equal to C1 by C2. That is, the lines are coincident, isn't it? If all are equal, then the lines are coincident. The lines are coincident. The lines are coincident. Okay. Third question. 6x minus 3y plus 10 equal to 0. 2y minus y plus 9 equal to 0. A1 by A2. A1 by A2 equal to 6 by 2. After cancellation, we get 3. B1 by B2 equal to minus 3 by minus 1. Minus 3 divided by minus 1. That is equal to 3. Now find C1 by C2. C1 by C2 equal to 10 by 9. That implies, or we can say that A1 by A2 equal to B1 by B2 but not equal to C1 by C2. If A1 by A2 equals B1 by B2 not equal to C1 by C2, then the lines are parallel, isn't it? The lines are parallel. The lines are parallel. Okay. Third question. On comparing the ratios A1 by A2, B1 by B2 and C1 by C2, find out whether the following pair of linear equations are consistent or inconsistent. That is, we have given we have given a pair of linear equations and we have to check whether the equations are consistent or inconsistent. Consistent means if there is solution, then they are called consistent equations. If there is no solution, then they are inconsistent. Okay. That is, first we have to find a1 by a2. a1 by a2 equal to 3 by 2. Coefficient of x, that is equal to 3 by 2. Now b1 by b2. b1 by b2 equal to 2 divided by minus 3. So we can say that a1 by a2 not equal to b1 by b2. a1 by a2 not equal to b1 by b2 means the lines are intersecting. If the lines are intersecting, then it has unique solution. Unique solution means if there is solution, then the system is consistent. So we can say that therefore we get the given system of equations are consistent. Okay. Second question. 2x minus 3y equal to 8. 4x minus 6y equal to 9. Find a1 by a2. a1 by a2 equal to 2 by 4. 2 by 4 after cancellation you get 1 by 2. Now b1 by b2. b1 by b2 equal to minus 3 by minus 6. Cancelling we get 1 by 2. Now we have to find C1 by C2 also because A1 by A2 equals B1 by B2. C1 by C2 equal to 8 by 9. Therefore we get A1 by A2 equal to B1 by B2 but not equal to C1 by C2. That means the lines are parallel. Lines are parallel means there is no solution. If there is no solution, then the system is inconsistent, isn't it? The system is inconsistent. Okay? The system is inconsistent. Third question. 3 by 2x plus 5 by 3y equal to 7. 9x minus 10y equal to 14. A1 by A2. A1 by A2 equal to A1 by A2 equal to 3 by 2 divided by 9. That is 3 by 2 into 1 by 9. After cancelling, you get 1 by 6, isn't it? Equal to 1 by 6. Now B1 by B2. B1 by B2 equal to 5 by 3 divided by minus 10. That is into minus 1 by 10. Cancelling we get, here it is 2 times. So it is minus 1 by 6. Therefore we can say that A1 by A2. Therefore we get A1 by A2 not equal to B1 by B2. Isn't it? A1 by A2 not equal to minus B1 by B2, because here it is 1 by 6 and here it is minus 1 by 6. B1 by B2 equal to minus 1 by 6. Therefore, we can say that A1 by A2 not equal to B1 by B2 means the lines are intersecting. Intersecting line means unique solution. Intersecting lines gives unique solution. If there is solution, then the system is consistent. That implies the system is consistent. Okay, the system is consistent. Fourth question, 5x minus 3y equal to 11 minus 10x plus 6y equal to 22. A1 by A2, that is equal to 5 divided by minus 10, that is equal to 1 by 2, minus 1 by 2. Now B1 by B2. B1 by B2 equal to minus 3 by 6. After cancellation, you get minus 1 by 2. Since A1 by A2 equal to B1 by B2, we have to find C1 by C2 also. C1 by C2 equal to 11 divided by minus 22. That is equal to minus 1 by 2. So we get A1 by A2 equal to B1 by B2 equal to C1 by C2. All are equal means coinciding lines. Coincident lines means there are infinitely many solutions. If there are solutions, then the system is consistent. So we have the next answer, it is consistent. We get the answer. The pair of given linear equations are consistent. Fifth question, 4 by 3x plus 2y equal to 8, 2x plus 3y equal to 12. A1 by A2, that is equal to 4 by 3 divided by 2, or we can write 4 by 3 into 1 by 2. Cancelling we get this equal to 2 by 3. A1 by A2 equal to 2 by 3. B1 by B2. B1 by B2 equal to, it is 2 by 3. Coefficient of y, that is 2 by 3. C1 by C2. C1 by C2 equal to 8 divided by 12. Cancelling by 4 we get, it is also equal to 2 by 3. So we can say that A1 by A2 equal to B1 by B2 equal to C1 by C2. If all are equal, A1 by A2 equals B1 by B2 equals C1 by C2, then we get coincident lines. Coincident line means infinitely many solutions. Infinitely many solutions means the system, given system is consistent, isn't it? Consistent. If there is solution, then it is consistent. Okay, thank you.